we ourselves, we do not make that kind of technology. We just use a kind of well-known technology. We call it HTK, and using Python as a glue. So Python in this project is at first it is used as a glue language. Actually, we use many our technology, but we use Python to do some glue effect, something like that. And finally, at first my student using JavaScript to do the final the last stage of demonstration. But currently, we have another member doing the pure Python version. Okay, so perhaps I can show the initial effects of that. Okay, so the major topic is so-called karaoke-style text read-aloud system. And I think karaoke is a very, originated from Japan, so perhaps I do not need to do more interpretation about that. Just have a very short demonstration like this. This is my favorite singer and my favorite song.
まずは暫定1位の席を奪い取る。もしもあなたと会えずにいたら私は何をしてたでしょうか。
Okay, so something like this. Perhaps I am that kind of person who like this kind of old style song. So perhaps that reveal my age. That is a quick, I think, 20 years ago or 30 years ago song. Okay, so something like that. I myself is a fan of karaoke, and I think it is a very good thing for language learning. So our initial motivation for this is that can we just use this as to be a language learning tool for foreigner learner the secondary language, or so-called L2 language. So this is the initial motivation for this kind of project. And there's a speech or a language learning technique called shadowing. Shadowing means that if you have a teacher and he have read aloud some text, and you as the learner, as a student, just follow. And the time lag as close as possible. As perhaps I myself can show some.
Speech shadowing, language learning technique in which subjects repeat speech immediately after hearing it. The technique is used in language learning. A demonstration can be viewed at the following.
Okay, something. Sorry. Yeah. Some manner like this. Just there's a teacher and you just follow it. But traditionally we need a real teacher, and you as the elementary school student, you just follow him. But that is not that effective in nowadays in modern times. So we just want to just like karaoke. Can we just you have the arbitrary text, and which perhaps is designed by some language teacher, or you yourself feel that that is quite interest for you, and you want to learn them, you want to memorize them, and so can you have a kind of karaoke-style thing to guide you to do that? Okay, so that is okay. So to do such kind of thing, first of all, we need to have a text. So first of all, for example, here is the example. I just copy, Wikipedia, a piece of text, a typical text, and then the first thing is we need to get the read aloud speech, just exactly the same those sound, and then that speech is in quality in quality issue, that is it must be good enough. Perhaps we do not expect it as natural as a human speak, But if it is good enough, I think that is good for foreigner to learn language. So the first step is that we need to get such kind of speech. Thanks Python and thanks Google. So these two, big issue put together. We found that there is a GTTS. There is a module called the GTTS. Some great men, some wonderful men, and just a very compact module, such that as long as we call this several 1, 2, 3, 4, 5 lines, we can provide arbitrary text, and then we get MP3 file for that text, something like this. And another thing is we need to do some digital signal processing because if you got some audio from Google, then it is compressed by MP3. But for our latter stage to do the speech recognition, it should be do some digital signal processing. And yeah, here we do not create wheel ourselves. Okay, we do not reinvent the wheel ourselves. So we just use FFmpeg. That is a very famous software to handle the multimedia data. So we just use this tool and do so-called decode from MP3 to plenary or to normal waveform. So this is what MP3, how MP3 be converted to a wave. By the same time, it is very good that you have an audio tool to view or to edit further your audio, your wave. But now we just use it, for example, we just use Audacity, but we just use it as an aid, as an help, such that we can view all audio signal. Okay, this is the Audacity. Today, all the software I show here is software open source software, so you can download everything and you can compile them, or you can just use them. Okay. So I just described the first stage, and the second stage is a little bit technology intensive. That need more technology. We call it the text-to-speech alignment. That means that the text is discretized. We have the first word, the second word, and the third word, something like that. But the speech, it is continuous in time. So we have the 0 second to 10 second. So now you have 100 words. You have 0 second to 10 second. How do you correspond, or how do you align them together? So this is our target. We just want to by input these two kind of thing, and we need to do some labeling. And for example, here we must have some computation about Wikipedia. Such a word is between 0.080 second to 0.870 second, something like that. So this is our target, our goal. We want to do such kind of a task. So to do such kind of a task, there are at least two levels. One is that is some grammatical level. For example, for a very long article, how do you segment them to by sentence? So we call that thing as a sentence level splitting. We just do wave splitting in sentence level. This is quite a straightforward. It is it seems no advanced technology embedded, because when we obtain those MP3, we just send the text sentence by sentence for each period or for each question mark, some important mark. We just send them to the Google and obtain get the speech. So when we get the speech, actually they are sentence by sentence. So here before actually we know the time segment. We time the sentence boundary in the so-called waveform, a very long waveform. Okay, the second part is the really technology embedded intensive. We need to do word level transcription, word level alignment. First of all, we need to do something that is quite common in speech recognition field. We call it the phonetic transcription. By phonetic transcription, I mean that we put a text, a normal text. That text can be here. I just take English as an example, but it can be, for example, Japanese, or it can be Chinese or something like that. So first of all, we need to do some, word or text to some phonetic symbol sequence of phonetic symbols, something like that. Original text like this, Wikipedia is multilingual, blah, 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 and then transcribe into a kind of phonetic symbol. Here we just use IPA. If we do such kind of thing, then the next stage, we need to deal many trivial things about IPA, or that is a kind of Unicode text processing. So in this part, our major effort is in how can we deal those kind of Unicode-based technology, text processing. Fortunately, I think that since Python's version 3, I think Unicode is it's original, it's source encoded. So for Python to deal with those Unicode things, that is quite natural. So yeah, so thanks to Python. Okay. In this transcription, I just mentioned that for if you want to deal with IPA symbol, or even Chinese character, or Japanese kanji, katakana, something like that, embedded with the Unicode is quite good. It's a wonderful thing. It's an awesome thing. So here we have 3 different modules to do such kind of text processing. The first is for English version. If you are input this English text, then I think this thing is the simplest thing, because English is itself a kind of how can I say that? It is based on phonemes. So if you just look upon each character as a so-called phoneme, I think that is not too different. So I think that is a kind of approximation, if you allow such kind of approximation. So of course you can core some cloud technology and do some IPA transcription. But here in our system, we do not do that. We just use the English word, the English character, or the Roman character as a phoneme itself. And so far, so good. Okay, so this is the simplest case. We just use English character itself, and using Python's regular expression module to do that kind of thing. And the second is for traditional Chinese. Traditional Chinese nowadays, I myself we have an open. Currently, it is a little bit shame. We do not have an open source module such that we can just using that do some phonetic transcription. But thanks Google again, and we just put our character there, and then got some phonetic symbol. And that is a kind of so-called pinyin. Pinyin is a kind of phonetic transcription about Chinese language. And for Japanese, actually, my team, and include myself, we are very unfamiliar with Japanese. I myself is a very yoji and level. So I just know a little bit about Japanese. But thanks to open source, I find 2 great modules. One is Mekabu, and the other is Romcom. And using these 2 kind of Python module, or I can do the use a very easy, very straightforward way to do the so-called transcription. So okay, so here, thanks Mekabu and Romcom. Okay, so go to here. We just in the speech recognition just go to the halfway. And so that means that we have a set of wave, and we have a set of so-called transcription. So using these two kind of things, so the most technology intensive is we must call the so-called speech recognition technology. And here we use a very well known for at least 30 years, I think. For its original release to up to date, 30 years. So that is a set of tools by C language, and so you can download it as long as you do some registration and compile it yourself to be in different OS. So using such kind of speech recognition technology, and we just use its most simple way. We call it called forced alignment. So any entry point for speech recognition technology, they have a so-called forced alignment. It says that as long as you have a wave, as long as you have the phonetic transcription, run such kind of technology, and it will provide you, and it will output for you so-called text or phonetic symbol, and to speech with the time symbol, with the time stamp there. Okay, so following, I just a quick review about the HTK Hidden Macro Model Toolkit. Actually, it is a kind of machine learning problem. So it like the other machine learning task, it divided as a training part and a testing part or recognition parts. So for this is all we have done in our we used in our program. That is, there are so many steps we need to follow, such that we can finish this task. So this is a detail. So I just show here, but I do not want to, or I do not have any time to do some detailed interpretation. So there are at least 8 steps to do such kind of thing. And the following several pages, I just visualize those concepts. For example, there is a step that we call the H copy that do some so-called feature or DSP signal processing thing for speech recognition. And we have a model training procedure training stage in machine learning. So we need to create some model for those phonetic symbol. And okay, so we have some training algorithm. Here, for each step, I just show that if you want to use HTK to help you do speech recognition, and all these steps is a bootstrap. Is a bootstrap, so you can start from all of this instead of read so heavy of the very hard to read menu. Okay, finally, we use the so-called Viterbi search. So, and this is all the summary. So, in the left side, we have the input. So, we have a directory or a bunch of WAV file, and with its phonetic symbol. And then using this set of HTK tool, and then in the right parts, we have the so-called aligned, text aligned file, time and symbol, time phonetic symbol, something like that. Okay, so here is some mystery or some magic about so-called Viterbi search. We do that kind of alignments. Okay, so this is the last, so everything come to here. Just that we have provided the most important thing, that is give you text, give you an audio, and then passing all our tasks, and then we have the so-called alignment file, something like the upper part. So we just do some demonstration about that. So I have a YouTube version and a local version. So I perhaps I just use the local version. It is.
Wikipedia is a multilingual, web-based, free content encyclopedia project supported by the Wikimedia Foundation, and based on a model of openly editable content. The name Wikipedia is a portmanteau of the words wiki, a technology for creating collaborative websites, from the Hawaiian word wiki, meaning quick, and encyclopedia. Wikipedia's articles provide links designed to guide the user to related pages with additional information. Wikipedia's articles provide links designed to guide the user to related pages with additional information. Wikipedia is written.
Okay, so this is the original English version. And we just show how you can slow it down. Oh, okay. So my computer died. Lose all energy. So, so, so actually, perhaps I have the another demonstration for Japanese and another version for Chinese, traditional Chinese, since I come from Taiwan. So you can go to that YouTube. So anyone can borrow me a computer. I just show those kind of things. I think the time is sorry. This my computer is quite old, so perhaps I bought it 3 or 4 years ago. So the battery is not that good. So let me okay. So let me just go to my blog. So why? No. Python dot blogspot dot I think dot tw. Okay. Okay. So all my slide you see a Python. Oh, so that is mine. sorry. Okay. So I'm not very good at yesterday. Thing. This is just say yes, right?
Yes.
Okay, good. So. Oh, sorry. I opened the wrong. That is tomorrow. This one. Sorry. Okay, this is a TK. So our TK version cannot show. Okay, so here is and I just go skip all the English parts. So, okay, that's okay. So I think that is a traditional Chinese version.
维基百科特色内容。特色内容是维基百科社群推荐的典范之作。展示在这里的文章、图片及其他内容，都是参与者在维基百科的精神感召之下共同协作努力的成果。
Okay, so this is traditional. For Japanese, I myself cannot make sure it is correct, so just for reference.
ウィキペディアは信頼されるフリーなオンライン百科事典。それも質量ともに史上最大の百科事典を共同作業で作り上げることを目的とするプロジェクトおよびその成果である百科事典本体です。
Okay, so that's all for the demo And so, okay, just skip this one. I don't know. Okay, so. So this is a browser use TK Inter, but it is under development. I have original, but now my computer is dead. So just show you here. Okay, I because it's quite mature, so I dare not put it in YouTube. Okay, so how can I use that? Okay, so I'm not very good. I'm not very. So perhaps so where I go? Sorry, I'm not very good at. Okay, so perhaps just go to the last and have some Q&A here. And okay, so actually it is an underline. So nowadays our goal is we just want to create some user interface as long as you put a text and you get everything. But now the process hasn't been not that automatic. So our future work is we want to make the whole process more automatically and then make the program more robust. So actually, I myself have not that much experience in programming, at least several years ago. Since I found Python recently, I retrained myself to write program, and so I just want to run an sprint, right? Sprint on the third days of this conference. So I just call your help. If you feel such kind of a task interests you, you can come on the conference, the sprint of this conference, and perhaps we can discuss more. And you use your Python expertise and to help me to make the program more wonderful. Okay, thank you. That's all.
So any questions? Okay.
Hey.
So the speech in your demonstration is also generated by Google TTS service, right?
Yeah, all speech. Yeah, English, Japanese, and Chinese.
In that case, your system might work poor on any other, voice. So where the acoustic feature is totally different. If the acoustic feature is totally different, it still works poor.
No.
Very robust?
No, very robust because we adopt a very strange technology. We use our speech recognition is not that Western speech. We use the so-called speaker independence. We do not do that kind of thing.
Right.
Because we do a very strange thing. Our purpose is not to recognize arbitrary speech.
Yeah.
Our purpose is just want to recognize those Google speech.
Mm-hmm.
We just use that kind of speech to our training material. So, in speech recognition technology, this is a kind of inside test.
Mm-hmm.
We just use this kind of speech and recognize this kind of speech. So the recognition rate is perfect.
Right.
Because just as I mentioned that, our goal is not to do real speech recognition. Our goal is we want to alignment those things. So even now, the speech is not come from Google, but myself, I have a speech myself, and I have, if I am a language teacher, perhaps I have some material, text material, I want to teach my students. So I write some, and I myself as a language teacher, so my voice, my pronunciation is perfect. Then I just read aloud them with a so-called, emotional speech, something like that. and that is perfect because we just use your speech to train the model and recognize your speech. So I think that is a very, I think that is a very, a little bit proud of that kind of, that kind of thing. So, doesn't matter. Okay.
Thank you.
Okay, thank you.
Did you try using it with a real song?
Song,
Yes, song.
that is a challenge. Now, because our first motivation is for language learning, but actually song is a good material for language learning. You know, sometimes you just like sing that kind of song. But, you know, just as my demonstration, the song is usually embedded in music, background music, that is a challenge.
With all the background music, you had just the singing person with all the background.
Okay, so that's okay. So if you just has the lyrics, okay, twinkle, twinkle, little star, something like that, and you yourself sing it, a single person without any background music, I think that's okay. That's okay.
You didn't try it.
I myself try it.
Try it.
Yeah, but my voice, I dare not to show.
It worked just fine.
Yeah, just fine. Yeah. Yeah, because in our system, we do not deal with the so-called pitch information. Pitch, you know, there's the frequency. We just use the yeah. So as long as you are, for example, if you sing, twinkle, twinkle, little star, or you just say, twinkle, twinkle, little star, just read aloud, and or you say, twinkle, twinkle, little star. Okay, yeah.
Time to finish
Okay,
the presentation.
So thank you so much.
Okay, thank you for your presentation.
Thank you for your community.